what is told here in question number 14. Particle moving in a straight line, okay, particle moving in a straight line covers half the distance, this is half the distance with speed 3 meter per second, okay. The another half of the distance is covered in 2 equal time, another half, this one, with 2 equal time, that is, if it is t, then also it is t, 2 equal time, with speed what, this is 4.5 meter per second and this is with 7.5 meter per second respectively. The average speed during the particle, the average speed of the particle during the motion. So total motion, for the total motion, what is the average speed? It is asked here. So what to do? At first, for this region, this one, time taken, how much? Let the total distance is 2d. Why 2d? Because if we imagine d, then there will be half distance, that means d by 2. It will be harder. So we imagine that total distance is 2d. Okay. So if the total distance is 2d, then d distance, half this one, d distance travelled by 3 meter per second, that is d by 3 equal to the time for the first one, t1, and the next 2 equal time taken with various velocity 4.5 and 7.5. So for this region, this region, the speed becomes what? Velocity v1 plus v2 by 2. Why this formula is used? Because total average speed for this region has been taken as 2 equal time, t and t, so divided by 2. When you face this type of numerics, you just add the velocities and divide by 2. Average, what is the average? Any two substances average is equal to divided by 2 and they are equal, so this one is 2, okay. So the average velocity will be what? 4.5 meter plus 7.5 meter by 2, that is what happens, 7.5, this one 5, okay. So 5 5 10, 7 4 11 and 1 12. So 12 by 2 equal to 6. So what we get? So what we get? For the first half, the speed 3 meter per second, and for the second half, speed is 6 meter per second. So time t1 equal to d by 3 and time t2 equal to d by 6. Now we apply total distance by total time. So total distance is 2d by total time. Total time is d by 3 plus d by 6. D by 3 plus d by 6. What happens? 6 2d plus d, that is equal to 3d by 6, that is d by 2, okay. Now total time and total distance. So total distance equal to 2d by total time, d by 2, that is multiplied by 2 by d, d cancel, that is equal to 4 meter per second. This numerics is very typical, but not too typical. So remember this. Question number 15 is as like as question number 14. Point object transverses half the distance. This one is distance, total distance, half the distance with velocity v0. The remaining part of the distance is covered with velocity v1 for half. This is v1 for half, and with velocity v2 for next half. Average velocity of the object for the whole journey. Let 2d, the distance, find out t1 and find out t2. t1 equal to what happens? d by v0, and t2 equal to what happens? d by v1 plus v2 by 2. That is 2d by v1 plus v2. Okay. Now total distance 2d divide by add this t1 plus t2 and divide 2d. Then you will get the answer. Now this numerics is very easy. Rajiv went to Delhi to Chandigarh and returned to Delhi. Odometer of that read 4200 km at the start trip. That is initially 4200 and 4460 at the end, and 4200 and 06422 260 total kilometer, and took 4 hours 20 minutes. Average speed, then 260 divided by how much? 4 hours 20 minutes. What happens? 4 hours 4 6 60 240 plus 20 minutes, that is 260. Here 260 minutes divided by 60 by hour, converting the hour. So multiplied by 60 divided by 260. Okay, 260 cancel, 60 km per hour. Next one is 4 cars ABCD moving in a level road. Their distance versus time graph are shown in the figure. Choose the correct statement. So distance versus time, here distance, here time. Distance versus time graph, what shows? I have told it previously, speed. Speed equal to distance by time. Okay, so this graph is showing the speed of the object. Now what happens? Angle, this angle is the slope. Slope is less, speed is less. Slope is high, speed is high. So C has highest speed, then D, then A, then B. Okay. Next question is displacement time graph for two particles A and B are straight line inclined at an angle 30 degree and 60 degree. Displacement time, that is displacement, and here it is time. So at 30 degree and 60 degree, this one is 30 degree, A and B has A and B has 60 degree. Find out the ratio of the velocity. It will be with tan theta, that is tan 30 and tan 60. As in class 9, the tan application is not given, so this question, do this question when you can learn the trigonometrical application. Okay. Next one is slope of a velocity time graph gives velocity time graph, slope, here velocity, here time. So y by x, that is equal to velocity by time, that is equal to acceleration. Next one is the area under velocity time graph. Area, imagine this one is graph and this is the under area. Area under velocity time graph gives what? Velocity time graph gives displacement. Here velocity, here time. If it is speed time, then it gives what? Then give distance. So remember, when speed time, then distance, and when velocity time, it is displacement. Next one is a body moving with initial velocity of 5 meter per second, that is u equal to 5 meter per second. Accelerate at 2 meter per second square. 2 meter per second square. After 10 second, that is time equal to 10 second. Velocity will be v equal to u plus at. u5, acceleration 2, time 10, that is 15 meter per second. Okay, sorry, I have told 15, it will be 25. Next one is a body thrown vertically upward with velocity u. The greatest height h will be what? So v square equal to u square plus 2gh, or you can say it 2as. 2as. Here s is equal to height, a is equal to gravitational acceleration, that is g. So the height will be, what happens? v0. Here v will become 0. When the object will reach here, its velocity will be, final velocity will be 0. So 2as equal to u square. So s is equal to u square by 2a or 2g. Okay. Next one is a car retards uniformly at the rate of 5 meter per second square. So retardation is equal to 5 meter per second square. Retardation is minus acceleration. So stops in 10 seconds. Stops in 10 seconds. Stop means velocity equal to 0. Final velocity. Initial velocity. So v equal to u plus at. Here it will be minus at. Why minus? Because it's retardation. So v equal to 0. U is not given. Minus a is equal to 5 and time is equal to 10. So it was 50 meter per second. Next one is a train starting from rest attains a velocity 90 km per hour in 2 minutes. Then distance traveled by the train for attaining this velocity. Attains a velocity 90 km per hour. So v square equal to u square plus 2as. You can apply this, or s is equal to ut plus half a t square. Okay. So what is given here? Final velocity is v 90 km. Here it is given. Time is not required. U 0. So we have to find out the a. How? V equal to u plus at. V final velocity is 90 km per hour, that is 90 into 5 by 18, that is equal to 25. That is final velocity is 25, u 0, because starting from the rest, a is not given. A into t time 2 minutes, that is 120 second. So a equal to 25 by 120 meter per second square. Mind it, 25 by 120. Now v square equal to u square plus 2as. V is equal to 25 square, u initial 0 starting from rest, 2 into 25 by 120 into s. So what happens? Cross multiplication. So s is equal to 25 into 25 into 120 by 2 into 25. 25 cancel. 2 60. So 60 into 25. 60 into 25. 0 150. 1500 meter. That is 1.5 kilometer. This numeric is very much important. Okay.